Alright guys, today we're going to talk about the real number line and addition of real numbers. Okay, now, real numbers are the set of numbers consisting of positive numbers, negative numbers, and zero. Now, when you're looking at the real number line, if you draw a number line, okay, zero is your origin, alright, and obviously you got your positive numbers to your right and your negative numbers to the left. Now, within real numbers, we have a group of numbers called integers. And integers are any numbers, like from -3 to 3, or we could look at it as basically, they are whole numbers and their opposites. Alright, now, but when we talk about real numbers, integers are just part of real numbers. Real numbers also include fractions and decimals as well as integers. So you could graph the numbers 1 and 1/4 and -3 and 7/10 on a number line. So you could draw a number line and you could do an approximate. Remember, 0 as our origin. Again, we have 1, 2, 3, 4, and so on. Your positive numbers to your right, negative numbers to your left. Okay, and we could graph this. We could put a point 1 and 1/4. Be right about there. And if we graph -3 and 7/10, would be approximately here. Okay. All right. So let me move this up a little bit. And let's get this out of our way. Okay, let me move this up again. Okay. Let's say we want to graph -2 and -1 on a number line, and then write two inequalities that compare the two numbers. Let's first graph it on a number line. So here's a number line. And let's see. Let's see. 0, 1. Let's see. We got -1, -2, -3. And we're going to graph. There's -1. There's -2. Now, what we want to do is we want to write two inequalities for this. Okay, so I could say -2 is less than -1, because the more to the left you go, the less the number is. But we can also flip that around and say -1 is also greater than -2. There's our two inequalities. So you can use a number line to help order real numbers. Alright, now let's talk about opposites. Opposites are 2 points that are the same distance from the origin, or that's 0, right, but are on opposite sides of the origin or opposite sides of 0 on a number line. So for example, -5 and 5 are opposites because they're each 5 units from origin, or 5 units away from 0. Now, -4 can be read -4, which is what we're used to. Or also, kind of knowing this now, we could also say it's the opposite of 4. All right? And that comes into play when we're talking about variables in algebra. Okay? You really don't want to read this right here as -a. Really, probably more correct way to read it is the opposite of a. And you really kind of got to get that into your brain. You can't assume, right? Do not assume that that the opposite of a is a negative number. For example, if a is a -7, then the opposite of a is the opposite of -7, or 7. So we could even look at, like, for example, if a was 3, then the opposite of a is -3. And if you had a equal to -3, then the opposite of a would equal a positive 3. So you got to really read a variable as the opposite of when you have a negative sign in front of it. All right, let's go to the next page. All right, now we're going to talk about what we call the distance between the origin and the point representing a real number. This is what we call absolute value. So the distance between a point and the origin is the absolute value of that number. So for example, we show absolute value with two lines, parallel lines on either side of the number, going vertically. So this, we would call this right here the absolute value of 5. Now the absolute value of 5 is going to be 5 because it's 5 spaces away from 0 on a number line. Now the absolute value of negative 5 is also going to be 5 because negative 5 is 5 units away from 0 on a number line. Now, here, we've got to be careful. If you notice, we have a negative sign in front of the absolute value. So this is like saying, what's the opposite of the absolute value of negative 5? So the absolute value of negative 5 is 5, but we're taking the opposite of that because we have that negative sign in front of the absolute value. So the opposite of 5 would be a negative 5. So you got to watch for symbols in front of an absolute value as well. Now, absolute value is never, oops, excuse me, I forgot to change that, sorry about that. Absolute value is never negative, okay? Unless like that third example where we had, that was a special case because we had, oops, yeah, because we had that negative sign in front of the absolute value. Because the reason being is, come on, there we go. Sorry about that, guys. Distance cannot be negative. That's why an absolute value can never be negative. And ultimately, absolute value, right? Distance can never be negative because absolute value is a distance. It's a distance from 0. Now, it's a little different here. Okay. Now, it's a little different here when we're solving an equation. Here we got the absolute value of x equals 8. Okay, so in other words, what number will work in for x to make that statement true? We actually have, there's two possible solutions, right? One solution is the obvious solution of 8, all right, because 8 is 8 units away from 0 on a number line. But another solution, the solution is 8 and negative 8, because negative 8 is also 8 units away from 0 on a number line. Now here with the second equation, all right, we said what can we take the absolute value of and get an answer of negative 4. This has no solution because remember said, help if I could spell right. There we go. No solution because remember we can't have a distance be negative. So there's no number that's going to be negative 4 units away from 0 on a number line. Okay. Now we're also going to be working with kind of proving things and justifying things a lot this year. And one of the ways we're going to do that is with something called a counterexample. Okay, a counterexample is an example that shows a statement is false. All right, now you don't need only one counterexample to show that a statement is false. Like when we talk about the properties, we'll talk about some counterexamples. All right, so let's move on and talk about. We're going to move on and talk about addition of real numbers. All right, in section 2 of chapter 2, we're going to be talking about addition of real numbers. Now, with adding real numbers, you really got to pay attention to whether the signs are the same or are they different. Now, if the signs are the same, in other words, they're both positive or both negative, you're going to add their absolute values, and you're going to attach the same sign. So for example, if you have negative 6 plus negative 5, the signs are the same, so you're going to add their absolute values. It's like you're adding the absolute value of negative 6 plus the absolute value of negative 5, which is ultimately 6 plus 5, and you'd get 11, but you're going to attach the same sign, so they were both negative to begin with, so your answer is negative 11. Okay. Now, two positive numbers you've been adding for years. 4 plus 17 is 21. If you think about it, you add the absolute values. Absolute value of 4 is 4. Absolute value of 17 is 17. And the answer stays positive. Now, we could go through, like on a number line, if you're, and looking at, well, if you're at -6 and going -5 would be going 5 to the left, you'd end up at -11. That makes sense. Or if you're already up 4 on a number line, you travel to the right, 17, you'd be up at 21. Okay? Now, adding numbers with different signs, okay, is a little different. You're going to subtract the smaller absolute value from the larger absolute value. And you're going to attach the sign with the larger absolute value. So, for example, -11 plus 6 is going to equal -5, because you got to think of it as your larger absolute value would be the -11, which would be 11 minus 6, which gets you 5, and -11 has the larger absolute value, so it's going to be a -5. Same thing here. -7 plus 24, you're going to think of as 24 minus 7. It gives you 17. 24 has a larger absolute value, that's positive, so the answer is a positive 17. All right, let's flip the page. All right, guys, let's talk about some of the properties of addition, specifically addition. Okay, first property we're going to talk about is the commutative property, okay, which basically states that the order in which the two numbers are added does not change the sum. So if you look at it algebraically, it'd be something like A plus B would be exactly the same as B plus A, right? Or like 3 plus a -2, you're going to get the exact same answer as -2 plus 3. Okay, both those answers are going to be 1. All right. Another property we want to talk about when we talk about addition is the associative property, which states basically that the way you group the three numbers when adding does not change the sum. So when we look at this algebraically, we're basically saying if you have A plus B and add that first and then add C, you can get the same answer if you have the same values, A plus B plus C. You could add B plus C first and then add the A, and you're still going to get the same answer. So if we look at numerically, you could have -5 plus 6 plus 2, and you could add the -5 plus 6 first, get 1, add 2, you'd get 3. We could take those same values, -5, 6, and 2, and if you add the 6 and 2 first, you'd get 8, then add the -5, you'd get 3. Both sides, obviously, you get 3. So it does work. Associative property does work there. Another property we need to talk about is the identity property. All right, and the identity property basically states that the sum of a number and 0 is the number. Okay, so what you add 0 to any number, you're going to get that same number back. So, for example, if you have A, you add 0 to it, you get A back. All right, or say, for example, you have -4. You add 0 to it, it's going to stay -4. It's going to, get that negative sign in there. It's going to keep its same identity. Okay, so and remember, we're going to be talking about an identity property for multiplication as well, but for right now, we're going to talk about talking about addition. Another property we need to talk about is the property of 0. Okay, property of 0 property says that the sum of a number and its opposite is always going to be 0. Okay, add a number and its opposite, you're going to get 0. This is sometimes also referred to in other textbooks and stuff as, it's also called the inverse property or the opposites property. In our book, it's called the property of 0. Okay, so for example, if you have A plus the opposite of A, you're always going to get, let's put that so you can see that distinctly, 0. Okay, so for example, 5 plus a -5, its opposite, will give you 0. They'll basically cancel each other out. Now these properties can come in really useful when doing a string of addition. All right, so for example, you might want to manipulate things like in these couple examples. We have 1 and 4/10 plus negative 2 and 6/10 plus 3 and 1/10. Now to me, what I can use is I can use the commutative property, make my life a little easy here, and deal with like the positives together first, then deal with the negative. Like I would think of this as 1 and 4/10 plus 3 and 1/10, and then put the negative 2 and 6/10, because I'm going to deal with I can add easier the two positives together. 1 and 4/10 and 3 and 1/10, it gives me 4 and 5/10. And then I can deal with the negative 2 and 6/10. Now there's the signs are different, so we're going to subtract, all right, and get an answer of 1 and 9/10, because the 4 and 5/10 has a larger absolute value. And we subtract that, we keep the positive. Now, technically, could you just go from follow order of operations and go from left to right? Sure, but these properties allow us a little leeway in putting together more compatible numbers. So like for example, in the second example, I want to think of this, we've got negative 1/2 plus 3 plus 1/2. Well, I want to think of this probably as I'm put 3, and then it's basically we have negative 1/2 plus a positive 1/2, and these two are opposites, so they're basically going to cancel each other. That's that property of 0, or opposites property. I know basically these are going to cancel, and I'm just being left with 3. So, all right, what I want you guys to do is I want you guys to pause the notes and then try the 10 practice problems, and then you're on yourself, and then you can play the notes again and check your answers. So everybody pause in 3, 2, 1, pause. All right, so hopefully you've tried these 10, try 8, can I count? 8 problems on your own, and let's get the answers now. Number 1, 7 plus a negative 3, equals 4. That's not a negative 4, that's a positive 4. Hello. All right, number 2, negative 8 plus 2 is a negative 6. Okay. 6 plus a negative 9 is a negative 3. Negative 2 plus negative 3 plus 6 is 1. And you might have done associative property and dealt with the negative 2 plus 3 first. Got negative 5 plus 6 gives you 1. Here, 5, you might have seen that negative 3 plus a negative 2 is a negative 5, and then applied your property of 0, or your opposites property, and gotten 0 for your answer there. Here, hopefully you remembered with decimals that you gotta line up your decimals, but one nice thing here, we got some opposites here. We got negative 7/10 and 7/10. Those will cancel, leaving us with 1 and 9/10. Okay, here, hopefully you maybe saw that you could add your fractions first. You get 3/3, or which is the same as 1, so what we really have here is negative 3 plus 1, which gives us a negative 2. And again, here, all right, you might see that you have 4 and negative 4. Those are opposites, so they're going to cancel. And negative 3 and 2/10 and negative 1/10, it's going to give us negative 3 and 3/10. So hopefully you got those correct. And on Monday in class, or the next time we meet in class, we'll be practicing some more with adding integers.